So hello dear students, welcome to the new lecture of the course, and in this particular lecture we are going to simulate PN junction as forward biased and reverse biased, which we had learned in our previous video. So basically this video is the continued form of the earlier video. Okay, so for that you have to install this memo play software, which I had told to you, I think in the second lecture, if I'm not mistaken, second or first lecture, whatever you can say. So after opening this particular software, that is memo play, you will get an application which is known as Play Store. Okay, and from Play Store you have to download this particular software, that is Electric Circuit Studio. Okay, so yeah, I just opened this particular software, and as you can see, we get the same interface as we are getting on the smartphone, okay, or on the mobile. Just the thing is that I had changed the theme to black, okay, or dark theme I had chosen, okay, just by going into the setting options. Okay, you can also do it very easily. Now let's understand the interface of this particular software. Okay, so my main intention to simulate the very basic circuit, that is PN junction as forward bias and reverse bias, is to is because to make you aware of this particular software, like so that you would be very much well acquainted with this particular software, what all things are available and what you can do and all. Okay, so as you can see, this is a small window which you get, and here you have to place component. Let's say, for example, if I want to place one component here, this is resistor. Okay, so I just click on resistor and I'm placing it in whichever place I want. Okay, and let's suppose if I want to delete this component, I will just click on it, and then click on the delete option, and yeah, this particular component got deleted. Okay, and there are n number of components available in this particular software. Okay, so you have to, let's suppose if I want if I don't want anything from here, so I will just click with the help of my mouse, and then I will move to my right. Okay, there are BJTs, MOSFETs, etc. If I want AND gate, NAND gate, again I will click on right, sorry, I will click here, and I will move my mouse to the right side. Okay, if you don't have mouse, you can go with your mouse pad as well by double clicking it. See, I don't know whether you can hear this voice or not. See, I am clicking on my mouse pad, and then laptop this mouse pad, and then I'm moving to left and right. I don't know whether you can hear the voice of it or not. Okay, so yeah, but I will suggest you should at least have one mouse, so that placing the components and then connecting it would be very much easy for you. Okay, and let's suppose if you have one component, and if you want to change its value, or let's suppose if you have voltage, if you want to change the voltage, then you should use this particular tool. Okay, we will come to it, and I will show to you how you can change it and all. Then to run the particular simulation, you should make use of this particular option, that is run. Okay, and if you want to change the orientation of any component, then you can use go with this particular tool. Okay, and this is redo and undo. Okay, I hope you know these particular things, and these are the certain things which are available, that is cut, and you can show the particular photo, okay, of that particular circuit, and it's up to you. And I will tell you how to use these particular things, but I think this is not at all required for us, because I will be just showing the circuits and simulating the circuits to you all guys. Okay, and main thing which I really loved about this particular software is this: you will get n number of formulas. Okay, Ohm's law, resistor in series and parallel, then voltage divider and current divider, which we had learned in course 1, inductors in series and parallel. There are n number of formulas available in this particular software. Inductor color code, resistor color code. I really loved this particular thing. So even if you don't know much about about the basics of conductors, you can actually use this particular formulas and then simulate the circuit. Let's suppose if I don't know Ohm's law. Okay, so first of all, here you get a number of options like simulate, read the book, and formula. So if you don't know formula, you can click here, and just a second. Yeah, as you can see, formula, they are also showing the formula, that is V is equals to I into R, and power dissipation formula, that is P is equals to V into I. Okay, and you can also simulate, but as of now I don't want to simulate this particular circuit. And let's suppose if you are being given with one numerical, let's suppose if if you want to change any like if you have a current as 10 ampere, okay, then what would be the resistance, sorry, if the resistance is constant, then what would be the change in voltage and all. Let's suppose if I'm making 100 ohms, so you should get, I think, uh oh, just a second, 100 ohms, yeah, you should get 1 kilovolt as your voltage, okay. So yeah, you can learn many more things from here. So that's actually nice, and I really loved this particular thing about this particular software. Okay, so now let's come to a point. I hope you understood a little bit about this particular software, and I hope you might get acquainted very well in future as well. But as of now, you just require this particular thing, that is, these are the components, okay. To move from, let's suppose, to move to right, you have to just click with the help of your mouse to any of the component, okay, and then shift to right, okay. Let's suppose if I want to move left, I will just click on any of the component and then move my mouse towards the right side to move left, okay. So this is how the things are going to work, okay. So now we are just going to simulate whether the PN junction diode, sorry, we are just going to simulate the PN junction diode in forward case and reverse case. We are just going to see that, okay. So for that you need a voltage, obviously. You also need a diode, which is present over here, okay. Let's suppose if I want this diode in horizontal direction, so as you can see, I can move very easily according to my need, okay. And yeah, I also need a voltmeter and ammeter, or ammeter. I will only take ammeter as of now, to check that how much amount of current is passing through the entire circuit when I'm connecting this particular diode in forward bias case, okay. So yeah, and one ground, this is the reference potential, and then you have to join this particular circuit. See, for joining you need to click on this particular option, and then you have to just click on 2 points where you need to connect this particular wire. See, again I'm clicking on this particular option, that is a pencil like option, then I'm clicking on the 2 points where I need to connect the wire. This is point 1 and this is point 2, and the wire automatically get connected. Again clicking on that option and then 2 points. Similarly over here, I just want to be the circuit in rectangular form, so I'm, yeah, fine with it, yeah. Okay, so our circuit got completed, and let's suppose if I'm at first, let's suppose if I'm giving
सारे
okay,
दोस्तों को बुला लो माई 11 सर्कल
extremely
पर
sorry, so
टीम
you will get certain ads, but I think you will only get 1 or 2 ads. So if you, let's suppose if you want to uh, keep the voltage as 0 point maybe 5 volts, okay, 0.5 volts, okay, and then click here and it get disappears, and then you have to, for running the circuit, you have to click on this particular option. See, as soon as I'm clicking on this particular option, yeah, as you can see, the circuit is getting simulated, and we are getting certain value of the current, and which is around, just a second, yeah, which is around 395 or 394 microampere, okay. So let me write over here, uh, let me take pen, okay. So for the our V1 voltage is V1, so when V1, which is equals to 0.5 volts, your current value of the current is 394 microampere. That means 394 into 10 raised to minus 6 into 10 raised to minus 6 amperes, okay. So this is the value for current when we provide 0.5 volt, that is external voltage, okay. So just a second, let me stop this circuit and let me change the value of the voltage. Now let's suppose if I'm providing 1 volt, okay, and if you want to change the unit of the voltage, so it's like millivolt, volt, kilovolt, megavolt, etc. I just want to keep in the voltage and then okay, and then click here so that this particular thing get disappear. And now I will simulate the circuit again, run. Sorry. So the value of the current is increasing, as you can see. Earlier it was in microampere, and now it is somewhere in 540 milliampere. Okay, so let me stop the circuit and let me write. When V1, that is external voltage, when I kept it as roughly around 1 volt, so I'm getting the value of current as 540 milliampere. That means what? That means it is 0.5 ampere. So you can see very clearly, let me see whether I'm getting options. Yes, you can see very clearly that here we were getting 394 into 10 raised to minus 6 ampere, and as soon as I increase the voltage, that means my V1, as I had explained you earlier, that when your external voltage, that is here the external voltage is V1, once it is greater than 0.7 volt, okay, and the p type or the anode of the diode is connected to the positive voltage of the battery, then automatically the diode gets forward bias and it will conduct the current very quickly. Okay, so as you can see, um, earlier it was in microampere and now it is in ampere, that is 0.5 ampere. Okay, and our V1, that is now it is equals to 1 volt, 1 volt, and obviously 1 volt is greater than 0.7 volt, so that's why we are getting the value of current as 0.5 ampere. And in earlier case your V1 was less than 0.7 volt, that is V1 was 0.5 volt. As you can see very clearly, in earlier case your V1 was 0.5 volts and it was less than 0.7 volt, that is depletion layer voltage, and that's why you were getting the value of current as how much? 394 microampere. In microampere you were getting the value. Now let's suppose, just a second, I will move to arrow, and then let's suppose if I'm changing the voltage to uh, 2 volt, suppose 2 volt. Okay, and again I will click over here so that it will get disappear, and now I will simulate the circuit again, run. So yeah, now you can see the value of the current is almost 2 times of this. Okay, not even almost, not even 2, in fact I guess 3 or 4 times of that. Okay, 1 by 2 4, yeah, almost 4 times of that. So you are getting value of 2 value of current as 2.41. Okay, so extremely sorry that there is some noise from outside. Anyways, which we will try to concentrate on this particular circuit. So now you can see that as soon as I provided a V1, as soon as I made V1 as 2 volts, okay, you are getting the value of current as 2.41 ampere. Okay, so you can easily see the change in the value of current. Okay, here it was just a second, yeah, here it was 0.5 ampere when V1 was 1 volt. Okay, and now when V1 is 2 volt, the value of current is 2.41 ampere. So that's why we can say that whenever we are connecting the PN junction diode in forward bias, that is positive terminal of the battery to the anode of the PN junction diode, or P type. Here basically in this particular region P type of semiconductor is doped, and here N type semiconductor is doped, and this is the cathode, we call it as cathode. So this is positive terminal of battery, that means anode is positive and cathode is negative. Okay, so when we connect this positive terminal of the battery to the positive side of the PN junction diode and negative to the negative terminal of the PN junction diode, so obviously it is in forward bias condition, and that's why it will allow the current to flow. Okay, so I can flow through it, allows the flow of the current. Okay, so let me erase each and everything, and then what we'll do is that, oh sorry, we will just reverse the diode. Okay, we'll just reverse the diode and then we'll see certain things. Okay, so I will just keep this particular thing, that is V1 is equal to 2 volt. Okay, let me erase everything. Yeah, fine. And then what we'll do is that, see, we have to stop this particular circuit, and then see, you have to delete this particular wire and this particular connection, and then you can easily rotate this particular diode, and then again you have to connect this. So you will use this particular option, and then first point and second point. Okay, and similarly over here by clicking again on this particular option, you will click here, first point and second point, okay, and the wire automatically gets connected, okay. Sorry. And then what I will do is, let's suppose for now I will keep this voltage as, let's suppose, uh, 1 volt. For now I will keep this voltage as 1 volt, okay. Again click here, and then I will simulate this particular circuit, run. And now you can easily see that here the current is flowing, but it is in picoampere, okay, it is in picoampere. So let me write certain things. When I kept the external voltage, that is V1, or the when the battery is providing the voltage as 1 volt, so you are getting current as 140 picoampere. That means what? You are getting current as 140 into 10 raised to minus 12 ampere. So you can see the difference, okay. Like in forward bias also you were getting in I guess in micro, yeah, 10 raised to minus 6. So you were getting in micro ampere, that too when you kept V1 less than 0.7 volt, okay. So now here it is almost double of that, okay. 140 into 10 raised to minus 12, okay. So you can actually see, sorry, not double, but almost 10 into 10 raised to minus 6 times of that, sorry, yeah. So you can see like the difference between both of them, okay. And now let's suppose if I am let me just stop the circuit, and let's suppose now if I am providing let's suppose 2 volt, okay. And yeah, and now I will simulate the circuit again, and now I will check the value of current. So yeah, you can clearly see that when I am providing V1 as 2 volt, okay, I am increasing this particular voltage, I am getting current as 240 picoampere. That means I is equals to 240 into 10 raised to minus 12 ampere. So you can clearly see that the current is increasing, but it is not increasing drastically as it was increasing in the forward bias condition. And looking at both the cases, that means, just a second, I don't think that I might get the different color option to choose. Let me see again. Yeah, by looking at both the options, that means see this one and this one, they both are in picoampere, and since they both are in picoampere, so that's why we will consider them as 0 ampere, okay, because there would be around 0 point somewhere around 12 zeros, and then you would be getting this particular value as 140, or maybe again 0.12 zeros, and then you would be getting the value as 240, something like that. So this particular thing or this particular number we would consider it as 0 ampere, okay. So that's why in reverse bias condition we always say that current like the diode does not allow the current to flow, so that means the current won't flow, okay. I'm indicating it with the cross, that means current is not allowed to flow in this particular circuit, okay. But still you may say that, sir, we are getting some current picoampere, that too in picoampere we are getting some current. And like in course 2 you told us that the depletion, even now in the second lecture you told us that the depletion layer increases, okay. So this is your junction part, and the depletion layer got increased, okay. And here the holes are stuck, and here there are electrons. Since there isn't any scope for electrons and holes to migrate, so how this particular current is flowing, okay. See, this particular current is flowing because along with holes, if you remember in course 2 we studied the minority charges, okay. There would also be some electrons, minority charges. Let's suppose if there are in p-type semiconductor, if let's suppose if there are 100 holes, then there would be 10 electrons around along with it, okay. Similarly in n-type semiconductor, if there are 100 electrons, then there would be at least 10 holes along with it. And this see, just a second, see, this particular 10 electrons and 10 holes, they are responsible for this particular current. Because of them you are getting this current into picoampere, you are getting the current picoampere. See, if you look very closely, these electrons will migrate over here, okay, and these particular holes will migrate over here, and due to this the current will flow. Okay, and due to this reason you are getting the current into picoampere. Since their number is very much less, as you can see, if you compare 100 with 10, obviously 100 is greater than 10. Again same goes over here. So due to this 10 holes and 10 electrons, there would be a current flowing through this particular circuit. Okay, I hope you understand, but it would be in reverse direction. It won't be in this particular direction. Sorry, I will erase this particular thing. It current would be there, but it would be flowing in this particular direction. Why? Because your electrons, see these red color dots, they are moving in this direction. And in course 1 only, in very first lecture, or I guess in second lecture of course 1, I told you that if electrons are flowing in this direction, then your current will always flow in this particular direction. So here also the current will flow in this particular direction. Okay, but it would be very less, almost equivalent to 0 ampere. So this is what I wanted to conclude to you all guys, and I really hope that you understood this particular software, how to use this particular software. Like, these are the components. Here you would get certain options which are required for the functionality of the circuit. Like this, with the help of this particular option you can change the value of the particular components. Okay, this I will tell you this particular option later on in the upcoming videos. With the help of this particular option you can actually simulate the circuit or run the circuit. With the help of this option you can delete the component. With the help of this particular option you can rotate the component. Okay, so I hope you understood each and everything that we had discussed in this particular video. Okay, I am ending this video over here. Thank you for listening me patiently. Thank you.